Good morning, everybody. Thank you very much for coming. We're talking about FregeFX, which is, Frege is a Haskell for the JVM, and here we have the language binding for JavaFX, JavaFX toolkit. Now, I consider JavaFX a niche technology. It's a substantial niche, but still a niche. It's not like JavaScript, where everybody does it. And Frege in particular is also a niche. Like Haskell is a rather substantial niche, but Frege is certainly a niche. So FregeFX, we are talking about the overlap of two niches, right? Which is the tiny niche. But it's an interesting one. And for a very long time, I thought I may be the only person in that niche. Could be. But I thought, it's open source, and at least it's an interesting one we're going to talk about. The title says explicit effects for JavaFX. So only after the talk was submitted and accepted, I realized that the word explicit has different meanings in US English, like explicit content or explicit language, explicit photography. That's not the kind of explicit that I mean, even though there may be some interesting pictures from my vacation that you may. Okay, so there could be. And the word effects in here is only partly connected, or very little connected to JavaFX effects in the sense of animations. Right? It is things that must happen, this kind of effect. Okay. And by the way, this is we're kind of a group where we can do this like above for a workshop or so. Whatever you want to see, just shout into the room. We do lots of coding, very little slides and mostly coding. That's me. I'm Dirk König, work for GNU in Basel, Switzerland. And I do lots of work in JavaFX, right? And for some reason, I went into this niche of Haskell on the JVM, and from Haskell on the JVM, for Haskell in particular, they say it's a pure language, right? And it is. Impurity means you want to have pure functions that only rely on their input arguments, and they give you back a value of the same arguments, always same value, and they produce no side effects. Pure function. Now, but we somehow have to produce an effect in our code, right? If effectless code is not worth running. Especially if you want to do JavaFX, you want to show user interface. And you want to react to user input, and that's all impure. How does that fit into the picture? And people often say, well, you can do it somewhat, but it's really difficult to do. And I played with other functional languages before and did UI stuff with it, and it was extremely painful. I remember in my youth, when I was young and needed some money, I did Prolog, a UI in Prolog. And the UI was a very simplified version of chess. It was a graphical thing, it was 2D, and you could drag it around and so. In Prolog, that was not a good idea to do, right? But anyway, so when people say this, I always like to take the challenge and say, well, let's try it and see where it breaks, see what it's not possible to do. Just to know, as an engineer, we want to know where things break, where they are applicable and where they don't. So I said, well, let's try. Good. It was the first thing that you have, and by the way, every time that I did this with Frege, I set myself a challenge where I expected things to break immediately or be awfully complicated, and it turned out to not only to be rather simple, but to be of real value. It's really added value. You will see that. So the general idea with effects in Haskell is, instead of applying them directly, you make a function that kind of assembles a recipe of what to do. Right? That's the principal idea. This is called an action. Right? So you're not directly printing to the console with println, but println is somehow it captures, like in an AST, it captures the idea that somebody should print and gives it to the OS. And then the OS does all the dirty deeds of printing and whatnot. That's the idea. You assemble a recipe. And now, when you do this, you're pure again, and you can work with your recipe. I hope we can show a little bit of this, because that's an interesting way of programming. In a way, it's kind of meta-programming. Not in the sense that you know it from other languages, but in the sense of we program, and what we program produces a program which is then executed, if you understand what I mean. Right? So let's see how that looks like. So there are special types that capture these actions. There's, for example, I/O actions. The type says, I will give you something that will be in an I/O string, for example, is a type that says, I will do some stuff, and eventually the action will produce you the string. You have to call it in order to get the string. Same for JavaFX actions. JavaFX is short for JavaFX in this regard. And then there's a second very important topic about this, and this is, since these effects are explicit, we can constrain them. And there are constraints in JavaFX. Who's doing any kind of JavaFX in his work? So at least some. So for the others, JavaFX has certain rules that you have to obey. For example, there's a button and text field and whatnot. And if you want to, just like a string, if you want to read their content, or if you want to set certain attributes on it, certain properties, you have to be inside the UI thread. If you do it from outside the UI thread, things might happen or they might not happen. You have to be in the UI thread for reading and for writing. Now these explicit actions that we have, they can actually enforce that you're always inside the right thread and doing things. If you're if you're not inside the right thread, it will not compile. That's the big benefit of it. These implicit constraints become explicit. You can no longer do it wrong. And there's the second one. You shouldn't do any kind of long-running operation inside the UI thread, because you will see the wait cursor or whatever, and the UI is blocked. Blocking UI, no, right? Even something simple as print into the console should not be done inside the UI thread. Could break, throw an IO exception, throw a null pointer exception, whatnot. You should not do this, because if in the UI thread an exception percolates up, the UI thread is blocked, nothing else will happen. That used to be the case extremely in Swing. It was somewhat mitigated a little bit in JavaFX. So these are the rules. Used to be implicit rules, become explicit rules in FregeFX. So we have less of these tricky errors. Why do things don't show up? And then you're hunting down. That's it. And there's two ways of doing this, right? You can just do it right, or you can let the language help you. You do it the same. For doing. So how does it look like when the language helps you? So here's one of the anthill simulation that we've seen just before the talk. I'll show it again. This is using software transactional memory, and this is how it looks in Eclipse when everything's okay. But if inside this context where you're kind of constrained of not doing I/O, this is one of these contexts that tell you STM not doing I/O is not allowed. If you then do I/O, for example, with the println, the UI, the IDE directly while you're typing says, not a good idea. And even outside the IDE, if you do it with a text editor, the compiler will fail. It's guaranteed by the type system that you cannot possibly do it wrong. So how do you go from Frege to something like JavaFX? JavaFX is as messy as can be from a Haskell perspective. Mainly because you have this notion of beans, and even more JavaFX beans. A bean is, from a functional perspective, the worst thing you can do. Because you even setting a property, you're not only mutating the object, anything can happen. You can have all kinds of listeners to the change of that object, to the change of that property. And it may go out to the web, or to the database, or via missiles, or whatnot. You don't know. You're setting a property and something happens. Or the bindstone goes on. It is, from a functional perspective, as messy as can be. But we somehow need to get control over this messiness. And this is by so-called native declarations. The first one is where Java, for example, is pure. So you have to have this statement somewhere in your code. We did most of that for you. Pretty much all of the JDK is already covered in native declarations. And it was my job to do the native declarations for all of JavaFX, for each class and for each method. So how many classes are there in JavaFX? Any guesses? 860. 20,000 methods. They all need a native declaration. And most of them can be generated automatically, but many need some additional thought process about it, because what happens in that thing? Because it's not in the Java type system, you have to look into the API doc and know what it does. For example, the lookup method on JavaFX scene. You can look up a certain element in the scene, a text field, button, whatever, by its ID or by whatnot, or by its CSS selector. And what comes back is, who has ever used lookup in JavaFX? Okay, so what comes back from the lookup? I don't even know whether it's even a node or a region. I guess it's object. Object comes back. You have no idea what comes back. And the lookup may fail, right? So you may get a null. There is no null in Frege. So if we go to the declaration of lookup, I can actually show you that in a minute. We have to say, and this is additional effort, the lookup might fail. So what we get back is not a node. It is not a JavaFX node. It's the maybe of a JavaFX node. So either it's nothing that comes back or the object itself. So this is kind of the configurations that we have to put forward here. So the first thing of a native declaration, first example is we go from string to a string, and this is some kind of encoding that comes from Java, and that's pure, and we can just call it like encode. We have chosen a name over here, and we can use that name. That's fine. And then there's something like println, which is, of course, in the standard distribution of Frege. You don't have to do it yourself, but here's how it looks like in the standard distribution. There is println under the name println. We do system of println. That gets translated pretty much literally into the code, into the Java code that Frege emits. And this goes from, let's put it like string. I know println is actually a little bit more involved, but let's say a string, to an I/O unit, it's called. Anyway, these parents call it unit, but it's some I/O action. We don't care what it gives back, it does some I/O. Yeah, we can then call it like println der König. But the println der König itself, when I call println, the type of this expression, that's not a statement, that's an expression. The type of that expression is I/O something. It's not nothing, it's not void, it's something. And this comes into play now. In JavaFX, let's say we have a text input control. All text fields, text areas, and whatnot have subclasses of text input control. If we do have, so the native get text which will be available as getText and getText under the same name. If I use the same name, then that's directly like so. I don't have to repeat it over here. So this is a function that goes from a text input control, takes a text input control, and returns not a string, getText, but a JVM string. That's a string that lives in the JavaFX context. It's a JavaFX action that, when performed, will give you a string. And we can use it like so. We say, text, please draw it out of this context. Here's my input field, getText. That's somewhere in the code this line could be. That would be okay. But if I would now try to just print in text, then this text over here would not be a string, it would be an IO string, and println would fail, but the compiler would fail, not at runtime, at compile time, say, you cannot just print this. Right? It's not possible. The types do not line up in your code. But what you can do is, you can use a special method that is provided by FregeFX that says, in IO, with this text, with this JavaFX type, please do this IO operation. That is, in IO, take this text and do this operation with it. And this is the only way, it's the only way that you can use in FregeFX to go from an FX type to an IO type. There is no other way. And this method makes sure that a new thread is spawned from the fork join pool. New thread is taken from the fork join pool. And your println is executed outside the UI thread. It takes care that this text is read inside the UI thread, and the println is executed outside the UI thread. It's all done automatically for you.
Because you often will redirect your prints that are standard out, standard in to something that's a GUI combo.
You may redirect your I/O somewhere where you want to do it, right? So the question, I'm not quite sure what the question was, though it's more an observation.
If you redirected your output
Yep.
to a screen component in your app, then that has to be written on the JavaFX application thread to the screen.
If you redirected the system out to a UI component, you may be able to do this in Java, but you cannot certainly do this. You certainly cannot do this in Frege.
Oh, I see.
It's actually kind of a tricky. I'm not quite sure whether I really understood well, maybe afterwards. I'm interested in that solution. That's cool. Good. So let's go over a number of examples. Right? You deserve seeing some examples. I'm going to show you 7 examples. So here, first I give you a short run-through. So this is from the FregeFX project itself. It comes with 2 examples. And that's the Hello World example of it, with some code that we're going to see, some buttons and what they do. Then I'll show you the Frege REPL. So there's a read eval print loop. Which itself is written in FregeFX. It's written in Frege, the whole thing, the REPL, and the visualization is with FregeFX, where you can type Frege code and it will get evaluated. This is all FregeFX. Then I'll show you a bit of a doodle. It's pretty interesting that you can directly do this interactively from the console, have this kind of doodle. It's kind of nice, I guess. And it works a bit like, turtle graphics. And if you think about turtle graphics, what can be more side effecting than turtle graphics? You pen up, pen down, move forward, so and so. That's all side effects, all the way down, all turtles down. It's side effecting like crazy. And still you will see that this code, the code that produces this doodle, is 90% purely functional. Only the very last line of the code produces some effect, because it first assembles what to do until it does it. Those are my vacation pictures. So we're gonna do a small picture gallery with some real effects, like the cover flow effect for this one. This is part of the Frege tutorial that I hold at Canoe. Then I'd like to show you a pond, whereas only this point is moving and bouncing off the borders here, because that has another interesting insight in it. Then I'll show you the ant colony, which is, from all these examples, the only one that is not me who has written it, so somebody else did it. A master student who was implementing software transaction memory for Frege. He made a visualization which is highly side-affecting the UI. I'll show you that at least, right? And tomorrow there's going to be a language shootout from the new languages, between Kotlin and Frege and, I don't know, JRuby or one of those. And the task was to come up with a chat application written in your language. So my solution was I make FregeFX clients, so that's desktop clients for the chat, and a microservice that contains the chat, and we go back and forth to the microservice. So it means it needs to poll the microservice and update this part here, the chat area. But it must also be possible to change the input field, input area in sending the post. So that's kind of, in this way you must read from JavaFX, do a side-effecting thing asynchronously, and when it comes back, you must feed the result back in. Right? So that's the typical thing that you do in a desktop application. It's kind of typical. So, and then I give you some entry points. So let's go through some of these examples. Oh, here. So everything starts on the web. On GitHub, there's a GitHub. Where's my GitHub? GitHub, Der König, GitHub. Oh, let's go to Der König because that will bring me to Frege. Here's Frege. And Frege has FregeFX, right? So you go to FregeFX. You can download this to your machine, and when you have that, when you cloned it or downloaded the zip, then you, I go open this in IntelliJ IDEA and go to, we are in FregeFX. Then on the command line, to open the command line down below, you can say Gradle U, or for me it's an abbreviation, I have that GW, Gradle U, make it your style, Gradle U, run. And then, oh, thanks. Oh, you need, if you have the Java 9 early access thingy going on, not a good idea. Java 8, you need to have Java 8. It will, if you have not Gradle installed, it will install it. If you, and otherwise it brings up the UI. It will compile everything, compile the FregeFX, compile the examples, and start the thing. Please click me for JFX action, thanks. So if we go back to that one, it says, let's say thanks, no. Print current thread to the console. So if there's an action listener on the button. So the first action was only changing something on the button. This is okay to run inside the UI thread only. That okay? Are you okay with me? Good. So second is I want to print the current thread to the console. This must be outside the UI thread. So if I do this and go to the console says thread is fork join pool common pool worker 1. Okay, that was outside. Bridge from asynchronous I/O to JavaFX inside UI thread. So I do some asynchronous I/O, and then I want to have the result showing back in the UI, because that also happens. You go to the web page and want to show the result of the web page, something of it, in your UI, because that's the usual thing that you do. that must also work. And this is what's showing the thread. Holding onto the thread, asking for the thread, can only be done outside. So this is then some asynchronous action. Make sure that this can only be done in I/O. Clicking on that one. And then there's an asynchronous action plus a wait for completion that I do in a special way. And then I do not only one button, but 5 buttons if you want to. That's automatically creating many UI elements. That's the kind of hello world that there is. Interestingly, pretty much everything that you ever need to do in a UI, you can copy from this code. That's pretty much all there is, right? Rarely do you need to do much more. So back down below here was thread is fork giant pool, printed outside the UI thread, asynchronous action, printed outside, waited for completion, proceed in UI. Now how does the code look like? The hello world in FR. So FR is on Frege. So this is the whole code from top to bottom. That's all there is. Somewhat not too much. So how does it look like? Well, we do have some imports. Okay. Here it starts. That's the main function. It gets some arguments like private, static, void, main, string, args, bar in Java. That's the Frege way of doing it. And FregeFX comes with a launch function. And the launch function takes some other function, which is here, that tells us what to do after starting. That's in JavaFX. If you do it in Java, you have this callback mechanism that you need to implement. So this is, I'm giving you a stage, and with that stage you can build your UI, and that runs in the UI thread. So here's my UI function. The UI function, here is a type declaration of the UI function. You can actually ignore this totally. It works if you don't write it at all. You don't have to care about the types. Frege will correctly care about all the types. It will all run, even if you're commenting this, right? It will be all fine. But if you want to be explicit about it, here it says, well, I introduced the notion of a family because you see all kinds of design quirks in your Java code when you try to do it from Frege, right? Because one of these design quirks is there's many different abstractions in JavaFX that have children. There's regions that have children and nodes that have children, and region is not a node, and so on. So if you want to say things that have children, you have to, there's no type for that. So I needed to invent a new type in the Frege world, and that type is family. A family is, has children. Hopefully, not everybody, but anyway. So, and if you have such a family and a stage, the build UI gives you back a JVX action for that type. So it's like type variable like generics in Java with, these angle brackets and the T. Good. So what we do reads somewhat familiar with this dot notation. We have a stage, that was one of the parameters over here. We have a stage, we are setting the title on the stage. That reads almost like Java. Pretty easy to foresee what it does. We also got a root element in here, which is the one that is the root of the stage. Build UI, the with stage function provided us with this root element and the stage. It is calling us with the two. And we can now add to the root element. This operator here, it's the lower than sign and colon, adds whatever this on the right hand side evaluates to the root. If you want, if you prefer, you can also use, do I have that over here? You can also use a function for this. So it is equivalent to doing add. And by the way, you see this is, you get code completion for that one. You can also do add same thing. And these backticks is the notation for like an infix operator, like an infix function name. Otherwise, you could also say, if you prefer, add. All these variants are equivalent. It's your style. These introducing new operators is always a tricky thing to do, right? Because people that know the operator find that very convenient, and as long as you don't know it, as long as it's not familiar, it seems like magic. There's no magic at all. It's just, you don't have to type so much. It's a one-to-one replacement. So I actually like to have this operator. So how do you create something that fits, that is added to the root? Well, we do have a VBox. We're creating a virtual box, a vertical box with the 5D spacings, setting a padding to it, and then we're adding multiple buttons. We're adding this button, we're adding that button, we're adding that button, and the buttons get action listeners attached to it. So the first one is a new button and has an action. This underscore is kind of that's a convention that you often see in Haskell. When you do a function that is not doing anything with the result value, it gets a trailing underscore. It's kind of a Haskellish thing, and I subscribe to that convention. So the button gets an action. So here's the function that does something with the action. It is setting the text on the button. When I click the first button, the button says, thanks. Right? Remember? That's how you do it. That's all there is. Right? Here's another function. This doesn't do an action, but an action I/O. This is an action listener. This will produce a JavaFX action listener, which will not run inside the UI thread, but from a fork join pool, in a thread from a fork join pool. And here we are now in I/O. This function over here is of type I/O. Right? And therefore, we can ask for a current thread. We can get the name from the current thread. We can println because we're inside I/O. This block here evaluates to I/O. That's how we distinguish these various pieces. And there's more of these kind of actions that you can do. Now it gets a little bit more elaborate. Doing something asynchronously yourself, plus completions and so on. That's more a bit more advanced stuff. You actually don't need those ones. But I want to give you the feeling how that looks like. Right? If you see the containment in the UI, the containment in the scene graph, you see it graphically by the indentation of that. Right? That's kind of nice. In the same way that GroovyFX and ScalaFX and so is also doing. But there is no special construct here in JavaFX that makes that happen. It's just normal function application that has this as a result. In FregeFX, there was not a single line necessary to make this containment thing happen. And the last one is also interesting. So I'm adding 5 buttons dynamically. And not only is it possible to do this at once, it is executing code. It looks like an fxml file almost, but it's not. It is executing code. So for example, I'm adding, there's an add all function. So this must evaluate to a list of JavaFX elements. How does it do it? Well, there's a list from 1 to 5. And the list of 1 through 5 gets mapped over. So I will create 5 things. So each number here will first be shown. Shown is the toString of Haskell and Frege. So I have the string element of it. And then I will append my string that I get here to the button. Button plus plus is a function that kind of is waiting for a string to come. Button plus plus, so it's button 1, button 2, button 3. And with this string, I'm creating a new button. That's how to read it. That's function composition. That's a bit Haskellish, okay, right? That's radically different from what you know from Java. Right? This is there is no way, you simply have no way of for loops or iterators or whatnot. That's just not there. Since you have no statements, you have no control structures. And you need to have this do it with a mapping function because there is no other way. Anyway, it is not shaky or so at all. It is absolutely 100% crystal clear what it does. And that's the nice thing about it. Good. Let's look. We said the next one in the presentation was our REPL. Let's go to the read eval print loop. Frege. Here it is. So the read eval print loop has a text area. You say 1 + 1, and it gives you a result. There also is a list view on the right-hand side, which maintains the history. So if I go the up arrow key, it is selecting on the right-hand side the 1 + 1, the last thing, and puts it into the input area. And if I do it again, it does this, and again, and again, and again, and again. Here's a map m println 1 to 100. I don't know what it does. Tell me. Oh, okay. It is mapping a lot of stuff. How about this one? Fibonacci. There's a one big number and one big number and a zip with the plus function and the tail of itself. Okay. It says I created the Fibonacci sequence. What's that? Fib. Oh, the Fibonacci numbers. The endless list, the never-ending list, the infinite list of Fibonacci numbers. And I can ask that, I guess let's see how a compile error looks like. Please give it at number 1, at position 100. Says, oh, I don't know about this getAdd thing. Do you mean this other thing? No, I forgot to import data list, where this function is in. We'll see the function is somewhere. The operator, the colon operator, is the very first one, which is now available. So Fibonacci so. Okay, do it again. Do it at one position to the next. So this is really quick, right, for Fibonacci 100. Just to give you an indication that it's not slow. And actually it's so that if you, well, let's go to 1000. I should have tried this before. But anyway. Not so bad, right? Let's go to 10,000. Not so bad. Well, I will not do any Fibonacci jokes here, mainly because, you know, the next Fibonacci joke is as bad as the first other two combined. But what you can do, and here's another thing, right? Here you can load into the REPL just any resource from the web. And here's one. There's :L for load, and you can give it a file or a URL, and it will load it, and you can play with it. So here's one that is on the web, and it's called stairs. Let's see where that loads it. Okay, module stairs. I can ask, what is stairs? Browse stairs. What does it have? Oh, there's a number of interesting values. There is something called fast of type IO unit. Okay, let's go to fast. Poof. Okay, that's our staircase that we have here. How about slow? Now this is how you paint the tool, right? that you have this square, and you from this position you're peeking over that other position and draw the line just a little bit longer than the edge. And then again for this one a little bit longer, and that a little bit longer, and this a little bit longer. While you're at the telephone or in a meeting, that's a good thing to do. That kind of looks nice. Yeah.
We haven't even brought your what you wanted.
Oh, that's all fine. Thanks. Interesting. So, how about this one? We do have a function called doodle, which takes a JavaFX graphics context and returns a list of I/O actions. These lists of I/O actions are probably the various strokes that we have seen. So if we're playing this, but not the whole list, only after 300, we're taking the first 300 of that. How does that look like? Oops, not that one. Dip, 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 dip. So that's it. The first 300. That was it. That was our same as fast, right? I'm going to close this one over here. Okay. Now we could, from this, before we take 300, we could actually drop some. Let's say we are dropping 299. And then we are taking, let's say drop 100 of these. We are not painting the first 100. And then we are not taking the next 300, we are taking only 3. How does that look like? Okay, that was position 100, 101, 102, 103. You see how that is painted, right? And now we take the next one, we're taking 4. Okay, you see the one from down below here to that one, just exceeding this line just a little bit more. And maybe take 5. There it is. Now I know you really want to see what the code looks like. There's let me see. Let's go back a little. So we had this 300, and we said, well, this playing is somewhat giving the graphics context to the doodle, and then it executes it. So we can play with this. The play is the I/O specific part, the JavaFX specific part. All the rest is only calculation. It's creating I/O actions. But we can play with these actions. We can remove some. As we have seen here, we dropped over some, right? We can be removing. But we can also add new ones in it. So we have this list of actions, and now we're adding stuff to it, to the list. By the way, what's this? Take 300 of doodle is of type. It's something. It doesn't play it. It gives us a list of I/O actions. So therefore, we can play with that. Take 300. But we can also, it's I/O actions. What could we possibly do? We could possibly, between every 2, insert a new one. And the method that does it is called intersperse. Intersperse. Okay, so we first have the full list, then we're taking 300, and then we're doing something in the middle of each single one, doing some I/O action. What could we do? Well, we could do a println. What's that? Println, say X, say JavaOne. Okay, I haven't tried this bit. Let's see. It did it, right? Good. I should try that stuff before executing. Anyway, so, but the really nice thing that we can do is we can play with the thread. We can go to the thread and say sleep 10. Now, with the painting of the stroke will be interspersed with the sleep 10, and then the next painting of the stroke with the sleep 10, and next. So we are creating this recipe, you know, like I started the talk. We are dealing with this recipe. It's a fully functional thing. It's without any side effects. Only at the very last end when we execute it, we are creating this recipe automatically. So the recipe now says between every 2 strokes, just make a small pause. Oh, that is pretty cool. We have a list of stuff. What else can we do with a list of stuff? A list of something. What can you do with a list of something? We can reverse it. Hey, good idea. I love it. Go? This is nice. Now, I'd like to give you the feeling how different it is to work in a functional language as opposed to where things happen and you're like inside this happening thing and you find your way around and hold on here and hold on there and do something. No, 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 no. You're preparing the whole thing and just let it go. So how does the code look like? Well, as you have seen, it is somewhere here, stairs, and let's see in Safari. This is what we loaded. It's not showing that nicely because there's no syntax highlighting to it. Let's rather do this in do I have some Finder over here? And go to, I have it at Der König, of course, somewhere on my machine, all the Frege files, and there should be stairs, this one. Okay, here you go. That's all it is. And it's all purely functional up to the point where we do the play, right? The play itself is sequencing over these functions that we have. That means it will produce the side effect and will do the actual paint. And we can call the play in a fast or in slow fashion. All the rest is purely functional. So we do have a point, and this is how you make a point. It's immutable. And we have a list of 4 points, like a quadruple of points, that is our trail. Well, we need to have for the bearing that we need to have for making the next line, we need to get to the last 4 points that we are dragging behind us. We are kind of moving these trail around, and have the last 4 points updating, such that we always know where to do the bearing over. And there's a start point, which is slightly tugged in, such that it all works correctly. And then the bearing is a function from one point over a second point to a third point. I mean, that's how it is. How do you do bearing, right? So you're kind of peeking over this. You're at this point, you're peeking over that point, and you get that point, right? That's how you do it. So how does it work? You make a new point, P, this is P, and what's the X position and what's the Y position? Well, the X position is from start and over. From the over, you diminish, you'd say minus of the start, plus the start, so to speak, and then 5% more. Right? That's the mathematics work out. But for doing the next step in the sequence, we have one trail of points, and we need to move that trail around from one trail to the next trail. A trail is a quadruple of 4 points. And one step is apply the bearing on the first point. We are bearing from the first over the last, getting a new point. And what used to be the first here becomes the second. What was the second becomes the third. What was the third becomes, what was the third over here becomes the last. Right? That's how it goes. And trails, all trails that we have, are just an infinite production of these steps. We iterate over the steps. It's an infinite loop going over the steps, starting at the start. It's a rather unconventional way of thinking about it from Java terms, but it's a functional way of thinking about it. Yep, and then we are connecting the dots. This is where the graphics context comes in. Here is the first occurrence of anything that's JavaFX specific. And even though it produces IO unit, it doesn't produce a side effect yet because it's not yet applied. We are only creating the recipe. And the doodle is the one that gets the graphics context from the environment and then produces that one. So that's playful. So I'd like to show you a little bit more. Good. And since we're actually running a little bit short on time, I'd like to show you at least what we end up in the Frege tutorial. Build Gradle with a cover flow. Yep, that's good. Running the Frege tutorial, because I promised some explicit content. This is it. It will not get more explicit than this one. My feed and the feed of my, at that point, 1-year-old daughter or so, or maybe even younger. So if I hit the right key, it does like so: right, 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 right. We have violet cows in Switzerland, you know. It's lilac, or how do you call that color? It's violet. And yep, so vacation photos, or to the left, or to the right, or one back to the left. So that's all animations and whatnot, things that you need to do in JavaFX. Right? You can do very easily. It's like a half-day tutorial where you end up with this kind of thing very easily. Good. And of course, since we haven't seen it before, do the software transactional memory, the visualization of that. Now this is kind of a simulation of an anthill. This is the anthill, and they all start there randomly, moving forward, but in a certain random fashion, picking between straight forward and left and right. So there's 49 different ants, each having its own thread. They're going forward. They prefer lines where there are dropped pheromones, which we see in green. While walking, they drop pheromones. They try to pick up food, which is the right stuff. And if they pick up food, they turn back and try to move back to the anthill and drop it over here. After a while, you'll see an emergent behavior, and that is these ant streets, right? After the transform one. So this is massively parallel, working with software transactional memory. Now, if we would not evaporate the pheromones constantly, everything would be green, right? So the pheromones also in an extra thread evaporate. So you see this also down below here. Now, there's also a reporter that reports how many how much food is there, how much food is in the home, how much food is outside, how many ants we have, summing up from who is currently looking for food and who is currently carrying food home, and how many pheromones there are in the whole world. And at no point in time you will see any missing ants, even though when they come to the same cell, only one can go in and the other one has to back off. So if you try to do this with locks, good luck, right? In software transactional memory, it's really straightforward. It's a straightforward solution to provide. So that's an interesting point. This has been done by a master's student that we had at Canoe, and he provided software transactional memory, and he actually made this visualization without telling me, and only after he left, a few months after he left, I found that one somewhere. He was really very proud. So that's a nice thing to do. And as you see, this is highly side effecting. This is highly producing effects. This is changing like crazy, and it's all purely functional, immutable. Right? The world, every single version of the world that changes hundreds of times a second, every single one is immutable. There's always new worlds being generated. And it's fast enough. So let's close with the final slides. So I promised to show you some examples. So this is the only one that we really need to work through for understanding FregeFX. All the rest follows from there. Here is the REPL, which is kind of the whole thing is kind of involved for doing all things correctly, because you have to make sure that even if things don't work out with your code, the REPL is not compromised and so on. So that's a bit involved. We've seen that one, which is kind of, I think, a very good example about the difference between functional UI programming and imperative modifying stuff. This one here is a pond that moves around, and I included it because it's in the tutorial. This one made me think about. It was a good example on how differently I think, after I've visited this world of functional programming, because it makes me think of, well, the next position of this ball that bounces around is a function of what? This is the kind of consideration that comes to mind from a functional perspective. Well, it is a function of the last point where it was, the last location, plus its vector, right, movement vector, and maybe the world around it to some extent. So that's the kind of thinking that one can apply. Okay. It works nicely. Seen that one? Haven't seen that one. If you want to see that one tomorrow, please show up in the language shootout. You'll see a microservice and 2 FregeFX clients. Here are the entry points. If you want to take a photo, then I'll give you a chance to do this. Otherwise, I'll make these slides available somehow. And there's a second slide for that one. So there's the GitHub project itself, the gallery, the chat, the REPL, and a few more videos. And I'll add another video, a screencast of that thing today. What is unique in Frege? Well, it's really different from Java, at least, with global type inference, with all this purity and so on. The bottom line is your code gets, if it compiles, it's most likely right, and it's extremely robust. There's much less errors that you can make in the code. And I always like to say, it's just a pleasure to work with, and everybody says this about his language, But it's true. So. You can pick every kind of this material. There's an awesome lot of really excellent material on Haskell. You can pick it up and use it in Frege without any change. It just works. And the best book currently is Haskell Programming by Christopher Allen and Julie Bornicki. That would be my recommendation. And there's massive online courses and whatnot. And Frege Goodness is a free ebook that I maintain, and some Frege specifics are in there, so it's worth checking out. Frege. So, say we can finish up. Time is mostly up, and unless there's a pressing question that you would like to pose. No?
Just curious, where can I want to read about like how it's even the technicalities of how it's
Technicality or something, you bet. At best, go to either from the Frege homepage. There is a forum, Google group forum, and you can ask there, and we'll ask questions, or go Stack Overflow, ask a question, and then we will answer all the questions. There's also a GitHub chat. If you want to keep it a little bit more private, that's also fine. Otherwise, just tell me. So there is the Canoe voting machine. It works like so. You go out and press the green button as often as possible. And the more you liked it, the more you press it vividly. Thank you very much. Enjoy the conference.